Okay, here we go. Today we're going to solve the system of equations by substitution. So before we had done solving the system by elimination, but today we're going to solve it by substitution. So we have to remember that our solution has to be x, y. Oop, made a tiny y there. X, y, right? We want the x and we want the y. Because again, this is a better way of solving than graphing. Because graphing we're reliant on a graph and we have to plot points, and sometimes the plotting isn't very accurate. By doing it by elimination and by substitution, which we're doing today, it's very much more accurate. It's exact. We're going to find the exact same answer. So today we're going to work on example 1, this one. Example 2 will be the next lesson. So today we're going to focus on example 1 here. So we're going to notice that here it says y equals 5x plus 14 and y equals 2x plus 2. Well, if you notice, these two y's are the same. This y is exactly like this y, right? So if you look at it at a balance, the left side is the same as the left side. Look at that. Y and y, they're exactly the same. Remember the equal, right? To the left of the equal, y and y are exactly the same. That means that since the left sides, the two lefts are equal, that means the two rights are equal as well. Well, what are our two rights? Well, this is the first right side of the equation, and this is the second right. So if those two are equal, let's set them up as equal. So I'm gonna bring down the first here, the first blue box here, and I'm gonna say 5x plus 14 equals to the other blue box, which is 2x plus 2. Now that looks like a simple equation that we can solve, right? We bring down our line of separation. I'm going to write down x here because my goal is to solve for x. So I'm going to I want all the x's here on this side. If you notice x equal here. So I'm going to bring this 2x over, and I'm going to bring it over, and it becomes a minus 2x. So if I want only x's on this side of the line of separation, I'm going to bring this regular 14 over here. So this plus 14 is going to become a minus 14 here, like that. So 5x minus 2x is 3x. And we have a positive 2 and a negative 14. They are not the same signs. So I have to subtract. 14 minus 2 is 12. And 14 is bigger than 2, and 14 is a negative, so that means it's a negative 12. And then I remember that 3x means 3 times x. So the opposite of multiplying is dividing. So I cross out 3 here where it's multiplying, and it goes over and it divides on the other side. A negative divided by a positive is a negative. 12 divided by 3 is 4. So I have my x. Look at that. I found my x. Now I need to find my y. And for that, we do exactly what we did on the previous lesson, where it was solving by elimination, was the third step. We bring over whichever one of these two equations. This is one equation, and this is another equation. Which one of those two looks like it's the most simple? To me, again, it doesn't matter which one you choose. When you plug in negative 4 for x is going to give you the same answer. But for me, the bottom equation is simple, is the most simple. So I'm going to bring it over, and I'm going to say y is equal to 2x plus 2. And then the next step is I have to plug in the variable that I already know. And I know x already. So I'm going to say y is equal to 2 parentheses negative 4 plus 2. Now the goal is to get y by itself. Look at that. That's the beauty of substitution, is that y is already going to be by itself here on this type of problem. So now I multiply. 2 times negative 4 is negative 8. A positive times a negative is a negative. 2 times 4 is 8. I bring down my plus 2 here. Nothing's happened to that yet. And I combine those two. A negative 8 and a positive 2 are not the same signs. So I have to subtract. 8 minus 2 is 6. And 8 is bigger and 8 is negative. So the answer is negative. So y equals negative 6. So my final solution is x comma y. X comma y. Negative 4 comma negative 6. That right there is my final solution. So let's take a look at a couple of examples that you're going to see on Delta Math. Similar, you're going to see on Delta Math. So look at that. So let's take a look here at this first example. And it says, solve the system by substitution. It says y equals negative 6x and y equals negative 8x minus 14. So, as we saw in the previous example here, since these two y's are equal, that means that these two here are equal as well, right? So let's set them up as equal. So I'm going to say the first blue, the top blue, negative 6x is equal to negative 8x minus 14. Look at that. Now I'm going to draw my line of separation here, and I want to get x by itself here on the left side. So I want to bring this negative 8x over to the right side. So the opposite of negative 8x is plus 8x. And negative 6 and positive 8 are not the same sign. So 8 minus 6 is 2x. And it's going to be a positive 8 because 8 is bigger than 6 and 8 is a positive. And here simply, since I move negative 8x over, only negative 14 is left. And now remember that 2x means 2 times x. So if I cross it out, the opposite of times, when I bring it over, is divide. Negative 14 divided by 2, negative divided by a positive is a negative. 14 divided by 2 is 7. And there you go. I have my x. Now remember, my final solution I want as x comma y. So I have x already. I solve for x. Now I want to solve for y. So remember, I have to choose which one of these two equations is the most simple. To me, the top one is the most simple because it's less busy. Remember, this is one equation and this is another equation. The top one is less busy, so I'm just going to bring that one over here. And I'm going to say y is equal to negative 6x. Then I'm going to plug in what I already know, which is x equals negative 7. So I'm going to say y is equal to negative 6, parentheses, negative 7. And I bring my line of separation, and I'm going to do y. I don't have to bring it all the way down because y is already by itself. And I'm going to multiply those two. A negative times a negative is a positive. 6 times 7 is 42. So where these two equations cross, the solution is x comma y. X is negative 7. Y is 42. There we go. All right, let's do one more example, right? So same thing, solve the system by substitution, right? If I notice that my y on top is the same as my y on the bottom, so that means that my blue up top is equal to my blue on the bottom. Look at that. Those two equations. This is one equation, this is another equation. So I can set up the, if y is equal to y, green equals green, that means that 4x plus 3 blue is equal to 7x blue. So 4x plus 3 is equal to 7x. Look at that. Now I'm going to draw my line of separation. Now this, instead of putting my x here on the left side, let me push this up a little more. Instead of putting my x here on the left, I'm going to put it on the right. Because look, 7x is already here by itself. So I'm going to move this 4x over this way. So I'm going to cross out positive 4x, and I'm going to bring it over as negative 4x, just like that. So this 3 just comes down just like this. 7 minus 4x is 3x. And remember that 3x means 3 times x. So that means that the opposite of 3 times is divide by 3. So 3 divided by 3 is 1, and I bring down my x. So 1 is equal to x. Look at that. Again, I'm going to bring over the simpler of these two equations. And the most simple one is the bottom one because it's less busy. So I'm going to bring the bottom one over, and I'm going to say y is equal to 7x. I already know what x is. X is 1. So I'm going to substitute x for 1. I'm going to draw my line of separation. I don't have to come down too much because y is already by itself here. And easy, 7 times 1 is 7. And look at that. We have 7. So my answer, again, remember, is in x comma y form. So my x is 1. And my y is 7. And that there is my final solution. And these are the type of problems that you're going to see on this particular assignment. Here is the top one here. And the same steps were done for this bottom one here to get your solution.